Hey folks, I'm going to show you how to use the law of sines. Now the law of sines can be a powerful way to find out information about triangles. But in order to use the law of sines, you need to know at least an angle and information about the side opposite that particular angle. So imagine that you're given a problem. You're probably going to be given a triangle, and in order for you to use this formula successfully for this video, I want you to pay attention for how I'm going to label the angles and the sides in this triangle. First is, let's say that we have an angle A. If you want to know where side A is, it's going to be on the other side. It's going to be directly opposite angle A. The same is going to be true for angle B. If you have angle B in a triangle, then side B is directly opposite that angle. Finally, if you have angle C, you'll have side C directly opposite from angle C. Now, in the triangle that I'm going to show you, I'm going to have triangle labeled A, B, and C. So that's going to make it easier for you. But as you get more practice and experience, you'll realize that triangles are not just labeled A, B, and C, and it will be up to you to decide which one is A and which one is B and which one is C. At some point, you're going to realize that the way that this equation works is simply by having an angle and then the side opposite that angle. But you do need one other bit of information about that triangle. You'll either need another angle or you'll need another side, and then you can make use of this formula most effectively. So the law of sines is A over sine A equals B over sine B. And of course, if you had side and angle C, you could also say that it's C over sine of C. So if you're given a particular triangle, let's say that I only wanted to calculate a triangle that looks like this, I only need to use the first two proportions. All I need to do is use A over sine A and B over sine B. I don't need anything regarding side C or angle C. So you can just use the first two fractions, and this is the way that you use the law of sines. So this is a classic example, and that's the information that's needed. Alternatively, you could have an angle and a side, and then you could have another angle. Okay, so if you have two angles and a side, that could also work. You can also use the law of sines in this situation. Now, there are different combinations that you can use the law of sines. You can either have A over sine A is equal to B over sine B, but you could also have A over sine A equal to C over sine C. You could also use this formula as B over sine B equals C over sine C. So you can use any combination of these three different forms for a typical triangle that is triangle A, B, and C. Now, as I said, as you get experience, you're going to see that the letters change, but at least for this video and for the purposes of learning the correct use of the law of sines, I'm going to stick with triangle ABC. Alright, so that's your introduction for right now. I'll see you at the end of the video to summarize what I showed you. Alrighty, in this video I'm going to show you how to use the law of sines, and here we have our triangle right here that we need to figure out, and the directions say, given the following triangle, calculate the length of BC. Alright, so BC is this angle over here. We don't know what it is, and that's what we're supposed to figure out. And just to give you a little triangle navigation here as far as using the law of sines, normally when we encounter a triangle, especially as basic as a triangle like A, B, C, the corners of A, B, and C represent the angles, and they're usually written in uppercase. The sides opposite the angle are written in lowercase. And so opposite angle A, which in this case is 55 degrees, you have a lowercase a that represents this side. So just keep that in mind, that the angles have capital A's and that the sides opposite that would have lowercase a's. So if I write out the law of sines using this kind of format, I would write A over sine A, B, lowercase b, over sine B, and C over sine C. So again, the lowercase letters represent sides, capital letters represent the angles. Now we're not going to need all three of these. We actually just need 2 out of the 3 in order to solve this problem. Question is, which of these do we need? Well, here's the deal. I can take a look at the numbers and the information that's given, and that's going to help us figure out what to do. Since we already know that we're supposed to figure out side A, which is the same as BC in case you hadn't noticed that, we need to involve this particular fraction. We also know something about the angle, right? We know angle A is 55 degrees. So we can put the angle in place here. So that's another reason why we need that. Over here we've got angle C, 42 degrees, and opposite that we have side C, which is 8. So we're going to need this one as well. So we're going to use A over sine A equals C over sine C. So let's just pull that out for a second. Alright, and this is really the formula that we are going to use. So let's substitute some values in and solve this problem. So A, we don't really know. We're not sure what that is yet, but we do know that we have the sine of 55 degrees here in the denominator. Over on this side, we know that the side opposite angle C is 8, so we put 8 in there. And then the angle C is 42 degrees. Alright, so now we have our setup and we're ready to solve the problem. I personally like cross multiplication here. So what I'm going to do is I'm going to cross multiply A times the sine of 42. And I'm going to set that equal to the sine of 55 times 8, or 8 times the sine of 55 degrees. It means the same thing. And then, of course, to get A by itself, we're going to divide by the sine of 42 degrees. Alright, isn't this awesome? You are getting it done. Okay, so A is going to be equal to whatever the result is from this calculation. So now this is where I'm going to my calculator, and here we go. So I'm going to type in 8 times the sine of 55, and then I'm going to divide by the sine of 42 degrees. Alright, so the result is 8.73, and of course this was side A in the triangle. The question described this as length BC, right? BC with a little line over it means side BC, so just for completeness sake I'm going to use the notation that came with the problem. Means the same thing, but I just like to finish the problem exactly the way that they asked it. So those are the steps in following the law of sine. So if you take a look, again, we only use 2 out of the 3 proportions, and that's true every time you use the formula. If you need more examples, take a look at another video. Otherwise, I'll see you next time. Okay, you just got done watching a video on the law of sines, so hopefully that made the example clearer for you about how to use the law of sines. And remember that when you're using the law of sines, you, at the very minimum, you need to know an angle, a side opposite that angle, and either another angle or another side. Now you can use the law of sines repeatedly, and if you're just given 3 bits of information, you can continue to use the law of sines to figure out everything about the triangle. You can use the law of sines to figure out all the angles, and you can use the law of sines to figure out the lengths of all the sides. So it's a very powerful tool. What is A and what is B and what is C? Sometimes that is going to be labeled for you if you're given a triangle like triangle ABC. But if you're given some other triangle like triangle JFK, well, then you're going to have to decide what is A, B, and C, and then the appropriate sides and angles opposite those letters. Alright, that's it for now. If you need more help, watch another video, and I'll see you next time.